Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Onakeno, who has just finished the course Linux Basics for Robotics, and he'll be giving us a presentation on that. So, as we always do, we want to see his code-based work on the real robot, and then after that, we'll get him to explain to us what he did and the logic behind his approach. So, without further ado, let me now hand over the platform to him so that he can begin his presentation. All right, whenever you're ready, Kenna.
All right.
All right, I think you should be maybe give us a gist of what you're doing as you go. Yes.
So I'm just setting up the what's going on here? Okay, fuck me. I'm just setting up the running some files that I need to run, some code I need to run to work on the robot.
Yes.
So right now I'm on the robot interface. That should have started running. Okay, yeah. And then I am doing this on separate terminals because I need all the terminals. Like I need about 4 terminals. First one is for the robot simulation. The other one is for the robot interface. And then the other few will be for the programs I wrote. So I wrote the obstacle avoider. Oh, sorry. Obstacle avoider program. I just need to check first. Yeah, I wrote the obstacle avoider program. Why is it? And then I also wrote the robot statistics program as well. So the obstacle avoider would help the robot to avoid any obstacles by itself, and the statistics would like show the data that it's seeing at that time.
All right.
Well, let's see what the robot is saying.
All right, maybe you can enlarge that a bit.
I don't know where the robot is right now. Okay, I can see now.
Yes, much better, yeah. So, okay, but is your script already running?
Yes, it is running, and it was moving, and it just stopped. So I'm going to check what it's saying on.
Can you? Okay. What I recommend is you terminate your script and then use the joystick or teleop to move it to a visible part of the circuit.
All right. So 29. And all the time as well. Attention already. Proceed. Okay. Then I'll move this.
I think try rotating it first. So maybe move it. Yeah, like that. Yes. So we can. Yeah, maybe to the side, the left or the right.
Somewhere. No.
All right. It doesn't look like it's responding. Okay. Try disconnecting and reconnecting again. So.
something here already.
Yeah. Okay. So let's now try using tail-up this time around. So bring up the camera window so we can see where it is. Okay. Is it responding to?
No, not yet. Yeah.
Yeah. Okay. Doesn't. Okay. It is chaining. Okay. Yeah.
Trying to
Okay.
get in direction.
Yeah. Move it backwards. I just drag it down. So.
Bring it down.
Yeah. Okay. Let's go.
No, I'm going to
It's already okay. So move it forward. Yeah. Should be okay.
Is that good?
Yeah.
Okay.
There we go. Yeah. Now you can run your
Let me
script.
set up.
Yeah.
Okay. I don't know what happened the first time.
Yeah, it's alright. So let's see how your script manages.
I'll just go first. And just a repeat of everything I did before.
Yes. You can close the Aravis window right now because I don't really
Oh, can I close which window?
the window that's in the center that's showing the red stuff there.
And then let me set up the statistics. The program is already running. I don't know if we can see that.
Yes, we can see it. Yeah.
And I'll just run this and.
Right. Oops. Okay. Alright, it seems to be doing well at avoiding obstacles. Alright, you can pause or terminate execution and then you show us what you did to have it do these maneuvers.
So, I can show you my code right now. Should I disconnect from the robot?
Yes, please. No, don't disconnect now. Just stop the scripts, and I think I'd want to see the execution of the robot statistics. Right. So enlarge that terminal, so we just see what's there, and you just give a brief description of what's being given out there.
Okay, I'm pretty sure I killed that, but it will have the information.
Yes. Yeah, it's fine. It's fine. Yeah.
Is it this?
It's a little bit tiny, but I think it's workable.
Let me make sure that this is the original. Yes, okay, so this is the statistics bash. So it's just showing like data that the sensors were getting that they accumulated. So this shows how like the distance between the front of the robot and an obstacle. So here you can see 271 meters. The left range is for the left sensors, the left scanners. So the distance here is 0.359. And the right range is for the right one.
Okay.
And then what's this thing called? Turning right is just telling you which direction is going to turn in. So this is like kind of like a precursor to what we're going to talk about. But the right range, since it is more than the left, the robot decides to turn right because with the algorithm, it moves to the direction that has the most space between itself and an object.
Okay.
In every like decision.
And okay, what's the parameter that's being set that's giving those messages set parameter successful?
Set parameter successful.
Yeah.
I won't say I am sure. There are a couple parameters in my code. I can open that up now.
Okay. Let's see that.
ROS2. SRC. I'll just read Maximus. What was Maximus? Sorry.
Yep.
For this, so I can see everything. Robot statistics talk.
Double click on the edge where the color changes, and then you can drag to the left or to the right. Yep.
Double click where the color changes?
No, the other side.
Yeah, okay.
On the right. Yeah, there we go. Okay, so explain to me which parameters were being set.
Okay, so they were in the obstacle avoider bash. They were setter and getter, and basically for the setter and getter commands, they would the setter command would set like values. So like they would set velocity, linear velocity would also set angular velocity. So linear velocity would be when it's just moving straight. Angular velocity would be when it was turning. So I think those are the parameters that were being set. And then for the statistics of bash, just like reporting all those parameters have been set, and then it also reports the distance and all these things. So it would echo out the distance, the direction that the robot is moving, which is where we saw oh, this is turning right, all those things. And that's basically what it does. So the parameters that have been set were the setter function.
Okay, all right. Let's see the obstacle avoider script now. I see in your script there's some echoing of acceleration values, but I did not see any in the display. What's going on there?
Let me check. Let me check the shell that I was in. Okay, so this shell was this one. Acceleration values. Seconds. Time to move. 0.02.
Yeah. So.
Very interesting, actually.
Did those values display before, or did you test it? And
I believe so. I tested it, and then everything was working fine.
Okay.
I can look at the code now and see why that might not be the case. So.
All right. So you can do that as you explain your obstacle avoider, because that's the most important one we want to understand. So give us a detailed description and explanation of what you did.
Okay, so my obstacle avoider program was based off of the robots, the simple patrol bash program that we were given before as an example. So what it basically does, it first sets linear velocity and the angular velocity of the robot to be 0. It's just like a safety function to ensure that like it's not moving as per given to the instruction. And they also set the obstacle avoidance distance called the threshold. So like that just says, oh, if it's past this distance, if the distance between the object is less than this 0.3,
right,
then we shouldn't move. Okay. Echo is just printing out this line here. Nothing too hard, and then we get into the while loop. So the while loop is just this continuous thing that runs the code, which allows the robot to move by itself and avoid these obstacles.
Yes.
So we use the getter function get, scan, left, free range that were defined in the construct Jupyter notebook. We use that to get the left scan range, we get the front left scan range, we get the front right scan range, we get the right scan range. And then what I did was that I assigned variables to all of them because we're going to use them to like help code and to check which direction is the best one to go to.
Yes.
And then I also made another some other variables just to make it a bit easier. So I have FL check, which is just checking if the front left scan is less than the threshold. And if it is, it will return 1. I have F check and I have FR check.
Okay.
Oh, sorry. This checks if FL check, I misspoke. FL check, F check, FR check. They check if the ranges are more than the threshold. I misspoke. I'm sorry. So that if it gives you 1. So we have a couple of cases. If the front left is not free, the front is not free, and the front right is not free, then this is what shows that, because if all the checks are equal to 0, that means that none of them are greater than the threshold. So we will check if the left range is more than the right range, and then if that is so, we'll turn left. Otherwise, if the right range is more than the left range, then we'll turn right. So turning left was 0.31416, approximately that in the angular velocity. So it would turn left. We'd first stop it because let's say the robot was moving forward. If the robot was moving forward and we don't stop it initially in this line here, then it would still be moving forward and turning at the same time. So we'd have to stop it and then turn it and then start moving again.
Okay.
So yeah, this is why we have this 0 here, and then it turns left. If the right range was more than the left range, we would turn right.
Okay.
We have a couple more cases where, for example, here front left is not free and front is not free and front right is not free. So in that case, since the front right is free, we'll turn right. Stuff like that. We use the same one that we use here. A lot of them are intuitive in that manner. This one is a special case where front left is not free, the front is free, and the front right is not free. So we just don't want it. It goes past the threshold. So what I did is a bit different from the example. What I did to ensure that if the front range is more than the threshold, plus I give it a bit of allowance because I didn't want it to hit into it. So of the delay, right? So if the front range is a bit is more than the threshold plus 0.1 meters, then we will just continue going forward at a linear velocity of 0.1.
Okay.
And then we'll do that until the front range is not greater than that value, where we would now shift the whole thing. Sorry?
I said okay. All right. Yeah. I did like the special case because it means you managed to realize some behavior that was not as expected, right? And you had to find a way of dealing with it. That's why I said, yeah, it's good. Okay, go on.
Yeah. We also have some more cases. So this is where we get into cases where we have two sides free. So the front is free, the right is free. And again, what we do is that we will, so for this one, if the front is free and the right is free, we turn right. And if the front left is free and the front left is free. If front left is free and front right is not free, we turn left. Because there's no other option. If the left is the only option, you have to turn that direction.
Okay.
Yeah. We also have some couple ones where all of them are free. So here, the left is free, the front is free, and the right is free. So if this is the case, and this was like my last case, so I just used the else statement. If this is the case, then we'll go in the forward direction because that's where we want to move. All of them are free, so you can go forward. And then we use the same thing that I used where you check if the front range is greater than the threshold plus the allowance that I've given, and then you move there until it isn't. So until the front range is not greater than the threshold plus 0.1, you just keep moving forward.
All right.
That's basically my code. Yeah.
All right. Thank you. All right. So I'll probably get into some questions now. So as much as this was about obstacle avoidance, there is still like very important Linux principles that you're supposed to at least get an understanding of, right? So One of them is let's say the issue of permissions, right? So the if you would want to like change execution permission for a particular file, right, there is a way of doing it in the terminal. But what I want you to do for me right now is to open your terminal and just show me a way of listing all the files and their permissions given to them, right? So in any folder that you've got files in, just can you do that for me? Right.
Can you
Okay.
see the? Yep.
Right.
Yep.
Now, can you give me a description of the various permissions? So let's take, for example, the obstacle avoider base, right? Which permissions does it have, and to which group do those permissions belong? So.
Okay. All right. So for the obstacle avoider, because the permissions are based on three different groups. There's the user, there's the owner first, then there's the owner, there's the group, and then there are the other users.
All right.
So the owner is person like people that made it, the group are people that like in that group that
Right.
have access to the file, and the other users is everyone else. And then we know what access they have based on these little characters here. So X dash R, that is for other users. X dash R again is for group. And then for the owner, that's XWR. So X means executable file. So any file that you want to, any program you want to run, you would have to give it the X permission. R is just read, which means that the people in that group that you just give it to, they can read the file.
Right.
And then W is write, so they can edit the file. Right now, only the owner can like write or edit the file between all these groups.
And the rest, they can only.
Yeah, so the rest, the other users, they can execute the file and they can read it.
Okay, all right, that's good. Okay, thank you so much, Keno. All right, so one last thing. So let's say you wanted to list all the processes that your machine is working with. How would you do it? Can you show me?
Okay, I believe I remember what PS4. I think that's it. That should be it.
Yep, there you go. All right, yeah. All right. Thank you so much. Thank you so much for the wonderful presentation, and we thank you for also giving us a very good detailed explanation of the things that are going on and some of the Linux principles. All right. So you just hang on, and we're gonna hold it up once you're okay. Sure.
Yeah.
Alright everyone, this was Keno's presentation, and congratulations to him for a job well done, and also for getting the courage to come and showcase his work. And would like to encourage all those of you who would want to do the same thing to do so, and you just have to schedule your appointment, and then you can come and showcase your work here. So until next time, keep pushing, ROS learning. Bye bye.